This workshop organized by the Technische Universität Berlin and the Institute of Strength Physics and Material Science since 2004. Very many years, sometimes in some years there were two. For example, this year there was already one German-Russian workshop in February. It was planned in Braunschweig, but due to corona restrictions was online, was devoted to the so-called problem of third body in tribological context. And this one is a very special one, not usual, because it is in the framework of the Days of Germany in Tomsk, and it is devoted to a broader scope of topics, history of science and history of collaboration in projects, but also scientific projects. And so for the announcement of the program, I give the floor to Professor Varvara Romanova.
Dear colleagues, I am pleased to announce the first presentation, History of Shattered Solution in Contact Mechanics, and the first speaker is Professor Popov.
Contact mechanics. The first contact mechanical problem was solved by Heinrich Hertz, 1882. It's Jan Snedden, a British scientist. Due to this publication in International Journal of Engineering Science in 1965. This is a very, very high-cited paper. As a matter of fact, maybe the most cited paper in contact mechanics, even more cited than the original paper by Heinrich Hertz. But in reality, the solution of Snedden was obtained not by Snedden. It was obtained by Gallin, one of the most known contact mechanicists of the Soviet Union in the late 1940s, and he summarized his findings in the book which appeared 1953, of course in Russian, in Moscow, and three organizations with TU Berlin, with BAM, Bundesanstalt für Materialforschung und Prüfung, and very intensive collaboration with the University of Stuttgart. And Varvara takes part at least at two very, very intensive for many years with the University of Stuttgart and also with Berlin. So,
Thank you, Mr. Chairman. Dear colleagues, before I start my scientific talk, let me say some words about our long-term cooperation with Professor Schmauder from Stuttgart University and his research group. We met with Professor Schmauder in 1995 when he came to Tomsk to give a course of lectures on computational mechanics and visited our laboratory. I and Ruslan were first-year PhD students, and we met with Schmauder again in 2001, 6 years later in Tomsk again at the conference on mesomechanics. We have really good friends. Since 2001, we have accomplished together in cooperation with Professor Schmauder and his research group over 20 research projects. He suggested us to study numerically deformation and use surface roughening in aluminum alloys. Resistance and led to plastic strain localization. So the majority of experimental and numerical studies into this effect were aimed at elaborating effective methods to suppress roughening, at least within certain scale. And our task was to study mechanical aspects of this with explicit consideration of polycrystalline structure. This slide illustrates steps of three-dimensional microstructure-based simulations and
that if two bodies are in contact, sliding contact, then they are either roughening or smoothing, depending on what was the initial roughness. And this interplay of smoothing and roughening is not really in detail understood, but is important topic. And there are two reasons for them. The one is what you say, that the processes in the volume due to stresses and heterogeneity of plastic deformation, or due to structure or to instabilities. And the second one is to wear, because also the wear properties are heterogeneous. What do you think, what is important? Is this mechanism or the other, the wearing mechanism?
I think these are different mechanisms.
Different?
They appear in different conditions. So in contact mechanics, in contact conditions, you directly apply your action to the surface. And in this case, the surface is free. And microstructural mechanisms from the inside produce this roughening. I think in contact problems, it would be the problem too. It would be the problem too, because you also treat polycrystalline material or any homogeneous material. So roughening would be produced by contact friction or something else. I think
we have a very, very broad thematic scope, as you can see here. And the Helmut Association has 4 international bureaus in the world, in Brussels, Tel Aviv, Beijing and Moscow. So you can see what are the kind of 4 most important partners. It's the European Union, or Europe, Western European countries, Israel, China and Russia. Okay, let's come to the Russian side. Science.
Of material science. The initiator of my work with Tribology was Elazar Gutmanos, and it happened in the Technion several years ago. The first joint project was moves using the known solution.
I work with Dr. Hocker, and my first visit was connected
mechanical properties. So just to motivate our study, let me show you this pyramid, the top of this pyramid. So it means it is ultra-high performance polymer. So it can be used at temperatures nearly, let me say, 250 Celsius degrees. So, and it can operate at this temperature for a long time. So it also kind of regular structural elements. They are comparable with the size of initial powder. So we call it like a cell-like structure. And
only one component of stress tensor must be non-zero in terms of uniaxial tension, but what we can see here, yes, the sigma BD, which is like main component in this case, may be symmetrical in respect to the average stress level. but for
laser powder bed fusion. So as probably some of you know, 66 weight% of cobalt, 28 weight% of chrome, and 6 weight% of molybdenum is the alloy, which has very cool, very great properties such as heat, corrosion, and wear resistance. And you industries, technology, science, so on, so like aerospace industry, medicine, dentistry, production of some, I guess all of you know, is the best variant to
and close the workshop. Thank you.